this video, we're back with series and sequences. We will be introducing arithmetic and geometric sequences and what are the series. So let's start this video with arithmetic sequence. Take a look at these numbers: 11, 15, 19, 23, 27, 31, etc. So if you look closely, between the two consecutive numbers, the difference is 4. That means any number is added by 4 to get the next number. So this one is added by another 4 to get 19. 19 added by another 4, 23. 23 added by 4, 27. And it goes to infinity. Here, we call the first number the first term, and some textbooks show it with A1, the other textbooks show it with T index 1. So both of them are the same. And this difference between two consecutive number is called D, or the common difference. So in order to find the common difference, you have to see what number is added to each one to get the next number. Or you can simply subtract a number from its previous one to get the common difference. So here, the first term, as I just mentioned, it's A index 1. The second term, it's the first term added by a difference, which is A1 plus D. The third term would be the previous term by another D, so A1 plus 2D. And it goes on forever. So as you can see here, each term is added by a constant. Here, the constant is positive 4, and this constant number is called the common difference. But it doesn't mean that the constant or the common difference should always be a positive number, or it should be a whole number. It can be negative and it can be a fraction. Okay? So remember, each number is added by a constant or subtracted by a constant. The two operations used here are addition or subtraction. And let's see what are the formulas. Let's do another example here. So the first term here is 80, the second term 75, and then 70, 65, 60, 55, and it goes forever. And as you can see, the numbers are getting smaller and smaller. Okay, unlike the other one, unlike the first example, the numbers are getting bigger, but here the numbers are getting smaller. So I guess here each one is subtracted from a constant. If you look closely, 80 to 75, that means 5 is subtracted from 80. It's subtracted by 5. And here again, it's subtracted by 5 to get 70. Again, subtracted by 5 to get 65. So the common difference here, that is 5. I can just show it. And as you can see here, this is very important, that the constant or the D for a specific arithmetic sequence doesn't change. So whatever the D is, it will be the same. So here, negative 5, negative 5, negative 5. And as you know, subtracting 5 is the same as adding negative 5. So another example here would be pi over 2. The next one is pi. Third term is 3 pi over 2, and it goes on forever. If you see here, the numbers are getting bigger and bigger. So my guess would be adding a positive constant. So here, as you can see, if I calculate, each term is added by pi over 2 to get the next term. So again, first term here, pi over 2, and the difference is pi over 2. the second term pi, the third term 3 pi over 2. Now let's talk about formulas and see how we can find the d, the sum of some terms or other things. So once more, we're talking about arithmetic sequence. So in order to find the difference, we can always find a term and subtract it from the previous term. And remember, the d or the difference should remain constant. So you can tell, you can just say a2 minus a index 1 should be equal to a index 3 minus index 2, and it goes on forever. And if they ask you to find any specific terms on the nth term, or it could be, let's say n is 6 and it's 20, let's say 20th term, so you can say a20, okay, an is equal a index 1 plus n minus 1 multiplied by d. Or there is another formula. You could say the previous term, if you have the previous term, add a common difference and get the an. Okay, so here the n can be any number, but remember, n cannot be negative because we don't have a term which has got a negative index. Now, another important formula for arithmetic sequence is sum of n terms. So let's say you want to know what is the sum of the first 5 terms or the first 100 terms. So n is a positive number, and here you want to add the nth first term to find the sum. So here, and we show it with s index n. So s stands for sum, and then it would be equal to n over 2 bracket a index 1 plus a index n. Okay, so this is one formula to find the sum for arithmetic sequences, or the other one would be n over 2 square bracket 2 multiplied by a1 plus n minus 1 multiplied by d. So which formula to use depends on the information given to you by the question. If you are given the first term and the nth term, you can simply use this one. But sometimes you don't have, you only have a1 and the difference, and you want to find the sum of the, let's say, the first 20 terms, so you better use this one. The video we will be focusing on geometric series or sequences. Let's start with an example. So here the numbers are 3, 6, 12, 24, 48, and it goes on. But if you can see here, the numbers are increasing, but they are not added, they are actually multiplied by a constant. So here, if you can see, the first term is multiplied by 2 to get 6. Then again, the same constant is multiplied by 6 to get 12. So 2. Here again, 2. So in geometric series, we call this a constant which is multiplied by each term, common ratio, and we show it with r. So again, from the first term to the second term, what is the constant that is multiplied by? So it's 2. Then again, 2. Then again, 2. So the r value is 2. And as you can see here, I have to emphasize it, either in arithmetic series or here in geometric series, the d value or the r value doesn't change. It should be constant through one particular sequence. Okay, so as opposed to the arithmetic series or sequences, here each number, each term is either multiplied or divided and by a constant, which could be positive or negative. Let's look at the general term or formula. So let's call the first term A index 1. The second term would be A index 1 multiplied by the R. The third term would be A index 1 R to the power 2. So take a look at here. Okay, A1 is 3 and R is 2. Having this piece of information, I can just build up this sequence. So A1 is 3, R is 2. So here, the second term would be 6. The third term would be 3 times 4. The fourth term would be 3 times 8, and it goes on. Okay, so having the first term and the R, you can actually build up or find different terms or all the terms for the sequence. Let's see another example. So here, the first term is 2, then 1, and as you can see, it's getting smaller and smaller. But let's find the ratio. So here, 2 multiplied by something to get 1. So I would know that it is, if you calculate it, you could say it is multiplied by 1 over 2. Again, the same ratio, 1 over 2, 1 over 2, and it goes on forever. But because this ratio is less than 1, all these terms are getting smaller and smaller. But in the first example, because the ratio is bigger than 1, all these numbers are getting bigger and bigger. Let's do another example. Here I start, the first term is 100, then 50, 25, 12.5. So as you can see here, the first term is 100, but the numbers are getting smaller. So for sure the R is less than 1. And I would say it is divided by 2. You can either say divided by 2 or multiplied by 1 over 2, which is actually exactly the same thing. So here, again, divided by 2, and it goes on forever. As you know, in math, division and multiplication are basically the same operation, and they follow the same rule. So at this point, we will introduce the formulas for geometric series. Please pay attention not to mix up or confuse these formulas with the arithmetic one. The first term, or how to calculate, here we will discuss how to calculate the common ratio, which we show it with R. Any term divided by the previous term, okay? So let's say this is a general formula. Let's say A, the second term divided by the first term, third term divided by the second term, fourth term divided by the third, and it goes on forever. It depends on what pieces of information you have. But as you can see here, these values wouldn't change. That means the R, the common difference, should be constant. It shouldn't change during one sequence. In order to find the nth term, so the n is a positive number and it could be a positive integer or positive whole number, and it could be, let's say, 9th if you want to find the 9th term. So A9, A index 9 would be the first term multiplied by R, which is the common ratio, to the power n minus 1. So let's say the nth, if the n is 9, so A9 would be equal to A1 multiplied by R to the power 8. Now, here we want to see how we can calculate the sum of the n terms. So let's say they ask us to find the sum for the first 20 terms. So the n is 20. So there are a couple of formulas here that I will introduce to you. So the S stands for the sum. N is the number of terms which needs to be added together. So A1 is the first term. Here 1 minus R to the power n divided by 1 minus R. So in order to use this formula, you need to know the first term and the common difference And then you should also know how many terms you're adding together. There is another important formula that I will introduce to you for infinite geometric series, because for geometric series, they can go forever. And remember, they are always multiplied. Each term is multiplied or divided by constant. So here, the sum of the n terms, which n is a very big number, it would be a, the first term, multiplied by 1 divided by 1 minus r. So here, I just want to mention that this a, it's always the first term, a1. Okay? I hope this video is helps you to understand the sequences better, and you can differentiate between the two differences. I will upload another video with practice time on sequences, and we will do lots of practice questions, usually from easy to intermediate and advanced. Please don't forget to subscribe to my channel. See you next time.